All right. Good afternoon, everyone. Welcome to this INT interpolation homework discussion. I will go through all the problems with you and answer a few quick questions if you have. So this homework is due next Monday, July 28th at 11:45 p.m. Okay. So in general, this homework, as its name suggests, talking about the like interpolation and helps you to understand how this works. So there are in general 3 questions, and compared to the previous homework, this is a little bit shorter homework. So you guys shouldn't worry too much about that. In general, I highly recommend you to watch the video and read the slides carefully before you start this homework. Okay, so I already highlighted this sentence at the beginning of this homework discussion notes. So please make sure you watch the video, okay, and understand what is interpolation and especially what is this cubic spline interpolation. Okay, so I think if you can understand the idea and the detail, so it's going to be fairly easy for you to address those problems in this homework. Okay, I will start the problems one by one. The first one is asking you to do to write down a function called myInterp. So this is a fairly simple question. So there are just you basically just write down a function and do the and output this YINT, okay, based on the different types of interpolation in the interp tab input argument. So there are 3 things that I think that will be pretty important for you guys. The first one is, for sure, you need to have some sort of switch or like a conditional if loop for you to look at this interp tab input, okay, and trying to pick up the right interp type once you are calling the function to do this interpolation. Okay, and the second one is make sure that your function is case insensitive. I think this case insensitive is also highlighted in the assignment. Okay, so you need to consider how you can do some sort of conversion. Okay, between the capital letters and small letters, so that it will be case insensitive. Okay, the key part of this my interp function is basically you call this function called interp1. Okay, and in this for those of you who are not familiar with this interp1, please just type in help interp1 and look at what are the different options you have to do this interpolation. So essentially, you have different ways of interpolation type, which is also reflected in the input. Okay, so there are 3 possible inputs in the interpol type argument: N, L, or CS. Okay, so basically the thing is just once you see, okay, the interp type is N, you just call this interp1 function with this nearest neighbor interpolation. Okay, and if you see the interp type is L, you still call this interp1 function, but doing this using a linear interpolation, and similar to CS, and you call interp1 and do the cubic spline interpolation. So this is a fairly simple function. It should be less than 10 lines of code in total. Okay, so but this one just give you a little taste about what this interpolation is, and if you're interested, you can take a look at the output and see what are the interpolation points look like. Okay, so this is just the first problem, and the second question is the longest one, and you need to write down several functions, and finally you write down this make spline to do this to do a fit a cubic spline to data points. Okay, so again, make sure you understand what is cubic spline interpolation before you start this problem, because in this in every sub-question, it requires the understanding of what is cubic spline interpolation and what is the equations you need to write down and what are the boundary conditions. Make sure you understand what's going on here. Okay, I find the video and the slides very helpful to help you understand the basic idea. So I think read the slides will be enough to do this question. Okay, the first part A. Okay, so part A is very easy. So you just write down a function called polyarray, and there's an input scalar h, and you just output this array as is shown in equation 1. Okay, so this is fairly easy. Okay, so but for your own benefit, please try to understand what is this equation 1. Okay, so if you read the slides or watch the video, you will see that this this P array will be used to do this matching condition. Okay, so that this poly array function will be called multiple times when you write down the matching condition for part B. Okay, so for part B, as I mentioned, you are given the input arguments x and y to be fit, and basically this part is just you're trying to write down the those bunch of M array and M vector. Okay, so so the dimension of this array has already been given, so you shouldn't worry too much about that. And be careful, so as I mentioned, you need to call the poly array multiple times for every time when you want to generate this M array. Okay, and you also have this M vector. I can go ahead and tell you that this M vector is just yk plus 1 minus yk, and M array, you just replace those h with sk plus 1 minus sk. So please look at page 22 of the slides in this module. It gives very detailed introduction about what is. I already typed in page 22 of the slides, so in the discussion note. Okay, so please take a look at that one. It is very detailed, and basically what you need to do is just trying to implement that into your code. Okay, so be careful. One more thing is the last row of M array. Okay, so you will see that in page 22 of the slides as well, because for the last row, which corresponds to the last model, okay, because you have no data on the right hand side of this data, you only have the data from one side. Okay, so in that case, the M array will be a little bit different. Okay, but you can find what this array should look like for the last row on page 22 of the slides. Okay, and part C is asking you to write down this boundary conditions. Okay, so so if you look at if you watch the video already, you will know that if you just write down the matching conditions, okay, so you are basically trying to solve you're basically trying to solve 4n minus 1 parameters using 4n minus 2 plus 2 equations. So basically you are you still need 2 more equations for you to solve this linear equation, linear matrix equation. Okay, because you have more parameters and less equations, so in that case you cannot solve the equations uniquely. So that's why people need two more boundary conditions to make sure that the number of equations and the number of unknowns are the same. And in terms of the boundary conditions, there are different ways of doing it. So for part C, first please make sure you understand what is the natural boundary condition, periodic boundary condition, not a not boundary condition, and specified and low boundary condition. So these 4 conditions are shown on page 28 to 31 of the slides. So 4 pages correspond to the 4 different boundary conditions. So consult those 4 pages if you don't understand what are these boundary conditions. Okay, and once you make sure you understand that, what you really need to do is just to write down this B array and B vector. Okay, so to be added in the M array and M vector, you write in part B. Okay, so I think for natural boundary condition, periodic boundary condition, and not boundary condition, the conditions are actually fairly simple. You just write down something, and you write down something for the B array, and the B vector is basically just 0 vectors. Okay, so be careful once you are about to use the specified and slope boundary condition. Okay, which means if your type is E, in that case, you need to, in addition to the B array, you also need to output B vector as well. So for the details of what the B array and B vector looks like, please look at the slides. Okay, and also make sure that the input, this is also input case insensitive in terms of the type, and you should also have some sort of conditional loop or switch to handle the different types of boundary conditions you want to have. Okay, so this is for part C. Oh, and one more thing, also for part C, if there are V1 and Vn, okay, so these are the 2 additional inputs if you use AND slope. Okay, so the thing is, like, if you use the other 3, the situation is much simpler. But if you use AND slope, you have additional inputs and you have additional outputs. Okay, so just make sure you understand how the specified AND slope boundary condition works. Okay. Okay, so this is the end for part C, I think. For part D, this is the final code for the second question. Right now, you have write down all the conditions you have to solve this kind of linear equation. Basically, it's a linear equality, right? It's a linear equation. I'm sorry. So basically, as I mentioned, you are trying to solve for n minus 1 parameters. Right now, you have 4n minus 1 equations. Okay, so right now, basically, you can just use the backlash operator you use all the time for the last few homeworks. Okay, so let me go through this make spline code with you. So this I'm seeing like this make spline is a little bit longer than the part A, B, and C, not because of its logic, but because you need to handle a lot of different situations, right? Because in this type, you have 4 different scenarios, which correspond to the 4 different ways of doing the boundary condition. Okay, so first thing, once you when you start writing down this function, first please trying to make sure that the input is making sense and return errors if necessary. So those inappropriate input are given at the bottom of page 4. Okay, so there are 3 different cases you should consider this as an inappropriate input. The first one is that the size of x data and y data are not equal. The length of x data is less than 3, and the x data is not sorted. Okay, by mean sorted, I mean the x data is becoming larger and larger. Okay, as the index increases. Okay, so you're gonna like check all these 3 and make sure that those conditions are met. Okay, if any conditions are not met, return an error and exit the function. Okay, and the second one is once you make sure that the input is okay, please first check the type of the input, right? The input has a type here, and there are four different types of input, four types of way of doing the boundary condition. Again, if the type is N or P or K, things are much simpler. But if the type is E, you need to make sure that you get the two additional inputs, V1 and Vn, as you did for part C. Okay, and then what you need to do is combine the matching and the boundary conditions using the function you wrote in part B and part C. Okay, make sure that you get the correct number of matching conditions and boundary conditions. Okay, so and in that case, you can just simply solve the linear equations using backlash operator. Okay, so it's still ax equals to b, this kind of equations you want to solve, but in this case, the output you want to do is you want to output this kind of coefficient of the cubic polynomials into a struct called f. Okay, so make sure you understand how to initialize and put the elements into struct, and also this struct has two fields. Okay, the first field is those bunch of coefficient. Okay, so that's you see you have 4 by n minus 1 double array. That's why I tell you that the total coefficient you wanna solve is 4 n minus 1. Right, so make sure that you put those coefficient into the first field called co-EFF. Okay, and the second field of the output struct is fairly simple. You just put the sorted x data in the input into this output. Okay, so you basically didn't do anything. Just put the input into the output, because that will be used for people to check the performance of the interpolation and compare that with the true values. Okay, so make sure that you can recall how you can do the struct manipulation. Okay, remember like how you can put some, how you can generate a new field and how you can put the data into a specific field you just initialize. Okay, so I think for question 2 in general, this is just asking you to do a like cubic spline interpolation, like from the beginning to the very end. Okay, so once again, please make sure you understand how the cubic spline interpolation works before you start this problem. Otherwise, you will get stuck anyways. Okay, so especially please understand why we need this boundary condition and what are the matching conditions. Okay, so basically for each data point, you have a bunch of conditions you can have, and those conditions are both included in the videos and in the slides. Okay, so here's the thing: we have some conditions for the beginning, for the first data point. We have some condition for the last data point, and we have some conditions for the intermediate points. Okay, as you may imagine, for the intermediate points, because we have data from both left-hand side and right-hand side, so we have more equations. But on the boundary, we only have the equations from one side, right? That's why we kind of lack some equations, and that's why we need to add 2 more boundary conditions so that we will be able to solve all the 4n minus 1 coefficient in this cubic spline interpolation. Okay, and that's how we have different ways of doing the boundary conditions depending on your objective, and that's how different scenarios are popping up. Okay, so once again, I think the most The challenging part is the specified end slope. It's not that hard, but you just have a little bit more input and output, and all the details are on the slide. So please make sure you check these before you start homework. Okay. All right. So the third one is called the basically evaluate the spline. Okay. Oh, I'm sorry. I have a typo here. It should be evaluate spline. So this is just to check the performance of the interpolation. Check the performance of basically the cubic interpolation you did for for question 2. Okay. So basically there are 2 inputs and 1 output for this function. The 2 inputs, the first one is x values, okay? So those x values are not necessarily equal to the x data, right? And there are just some data point, but please make sure that there is no out of range data in x values, okay? Let me specify x values. So what I mean by out of range data is like all this x value, all the data in the x values should be greater than the smallest value of x data and be smaller than or equal to the largest value of x data. So basically, the x values should be included in the x data in terms of the range, okay? Because within this range, we have a nice interpolation of the data points using the cubic spline interpolation. But beyond that data range, we didn't do any interpolation, so the result may not be reliable. That's why we first want to make sure there's no out of range elements in the x value input. So basically, what you're comparing is the range of the x value and the range of x data you stored in this S struct. So recall that in the S struct, you have 2 fields, right? 2 fields, right? The first one is those bunch of coefficients, and the second one is those data that you use to do the interpolation, right? And what you're comparing is just the x data and the new x values you have in the input of this evaluate spline function. Okay, so what you're really trying to do is you're trying to use the model you build, okay, and use the new x values you have to output the new y values, right? So of course you want to kind of have some sort of for loop, right? Because you need to go through all the x values. For each x values, you want to output a y values there, okay? So, and for each x value, what is the most important part of this question is you need to find which model you are trying to use, because you actually have n-1 model, right? So which model you are trying to use. So that's the most important part for this evaluate the spline function, right? So what I suggest you to use the find function, definitely, okay? You want to find the index of the model and x data you want to use for given x values, okay? So what we're really trying to looking for is the index of the first element in S that has x data larger, that has x value larger than the x data, okay? I'm sorry, I think I need to change something here. X values larger than x data. Okay, so remember those x data are actually sorted, right? So as you go through, so the first x data might be very small, okay, and once you, it should be smaller, okay. So the first x data might be very small, okay, and as you go through, the x data will be becoming larger and larger, And until you get a x data that is larger than the x value, okay, that x data and the corresponding model is what you need to use to evaluate the performance of the function, of the cubic spline interpolation function you have. So recall that each the model fxk, the model fk is working in the range of data sk to sk plus 1, right? So after you are given a new data, you are trying to put your new data into the zone between sk and sk plus 1. So you're really trying to find out, okay, so where should I put the new data? Okay, because you know that your new data should be within the range of your feeding data, right? And you're just trying to put a specific new data into some sort of area in your feeding data there, and you're just trying to use that model, because for every sk to sk plus 1, you have a different model, right? So you're just trying to put your data into some specific zone and use the model that represents that part of the x data, right? So this is the most important part to solve this evaluation of spline function. Okay, so and once you have determined which subfunction, which submodel you want to use, and what is the x data you want to use, you can just go ahead and use this poly value function in MATLAB. This is already given in MATLAB. So if you haven't used this function before, just type in the help function, okay, help polyval, and see how it is defined, okay. Make sure that, because if you look at page 4 of the homework, okay, the coefficient of our model is defined as A0, A1, A2, and A3. Okay, please check and make sure that the poly value function is also defined in this way. And if not, you might need to flip this coefficient and put A3 as the first element to make it consistent with the definition of polyval. So make sure that you check whether they're consistent or not. Okay, so once you're done with this part, you should be able to get one y value for a given x value, okay? And then once you do the for loop, you basically get a bunch of y values and a bunch of x values. So in that case, you can basically try the example given on page 5 and 6 of this assignment, and trying to see if you can get a similar figure as figure 1 on page 6. Okay, and if you get similar figure, probably that means you should be good. Okay, so I think that's the end of this homework. I think basically this homework is not as complicated as the previous ones, especially the linear regression, or those for example, that linear programming problem. So as long as you understand how this linear interpolation works, okay, this homework should be fairly straightforward. Okay, so that's what I want to talk about this homework. So any of you has any quick questions? Yes, I personally think this is not as difficult as the LP homework, both in terms of the number of questions and also in terms of the logic issues you need to work on. So don't be too worried about this homework. Okay, so if not, I will first stop this recording, and